Hi, Michael and Anthony and Marty. Thank you so much for having Guise AI on today for OpenShift Commons. Guise AI is a edge modeling platform company with a no-code, low-code solution. They will empower you to have your models ready to solve real-world problems from quality assurance, image recognition, computer vision, and much, much more. Models at the edge are able to be repeated and scaled with their solution. You can pre-process your data at the going to save you so much money on cloud costs or moving that data around, giving you control over your data. Retraining and having more correct models, feeding the models in a very point and click fashion, making it easy to manage entire enterprises and multiple deployments of models with their offering. And when you combine that with Red Hat's open source model, you could have an AI platform anywhere and everywhere, offering sovereign data science, where you can build the models to make them bringing you the most sense for your business. Red Hat can help you deploy the models where they need to run, making it repeatable, scalable, and enterprise ready. And with that, I'll kick it over to Lindy. She's the COO of Guise AI, and also we have Naga, who is the CEO. Thank you, Lindy.
Thank you guys so much for having us today. We're excited to be here, but also just want to talk about the criticality of the partnership with Red Hat and why we're here today as well. And that what Red Hat has done in terms of creating enterprise grade, open source software, for customers. But has done it in a way that's agnostic. We've modeled a lot of what we've done after that as well. In terms of we believe that a solution for the customer has to fit the customer. It can't just solve a problem. It has to solve a problem in the way that the customer needs that problem solved, right? And sometimes it's just in design, but also, John and I've had deep discussions on this. There are no, unless you're building something from scratch, there are no greenfield opportunities. It's wonderful when a customer comes to you and starts talking about, they want to modernize, they want to do this, they want to do that, but you have legacy equipment in there. You have legacy systems in there. Anything from SCADA systems out, other supervisory layers. You have other ISVs, other software packages. So how do you bring all of these things together? And I think where our partnership works very well is Red Hat brings it brings their stuff to the edge, but then we fit very well together in terms of our expertise in, depending on what your nomenclature is, either the device edge or the far edge. And sometimes that refers to distance, right? Sometimes you have very remote environments in which you have to deploy, but sometimes device edge is right on the factory floor. And so we define it really as, where is that data being created? And why am I starting here, especially on, when we're talking about patterns? You have to talk about where that data is being created, and the fact that that data isn't new. I'm gonna share my screen and pop in here now. So presenting today, as Danielle graciously introduced us, my co-founder Naga Rayapati, myself, and then John Archer from the Global Edge team as well. And so, as we're talking, it's critical to really start harnessing that data. And why is it critical to do that? Because as you look at the changes in enterprises over the last several decades, as we go from just doing one thing at a time to automation to cloud to data center, as we start really looking at that data and we start doing things with that data, we still have a garbage in, garbage out problem. Sometimes more data is just more data. It's not good data. And so we really have to look at how we access that data so that we can feed decision-making, so that we can feed data science, so that we can feed analytics, so that we can automate processes, right? And so, what's shifted is having to do things either in the cloud or the data center, which doesn't always work, right? Getting back to that original idea of how do we bring solutions to clients in the way that they need them brought to them, right? And so you need the right tool for the right time. And that's why it's really critical now that we've come to this interesting inflection point in the industry where we have smaller and smaller SOCs, and we can now optimize AI models to run on these very small devices, right? So that you can, the advantages of, AI at the edge, doing inferencing right where that data is being produced, you can do real-time decision making, right? You can increase, the agility and the flexibility of operations because you can automate, and you can automate in the right way, right? When latency matters. Or early in my career, I used to work with a lot of manufacturing companies, and somebody was like, well, what do you mean, when latency matters? And I was like, well, I was on the manufacturing floor, and they were very proud of this new state-of-the-art bandsaw that actually, had enough intelligence built into it that it picked up any moisture in your fingers so that you didn't lose a digit when you came near it, that if it detected that a finger was nearby, the bandsaw, stopped on a dime. That's when latency matters, right? You don't want to lose an appendage. But again, also, you can use your resources more efficiently. When you start talking about targeted, edge AI use cases, these things run on CPUs, right? You don't need, all the power, but also the cost of running on a server in the data center. You can run on cost-efficient edge devices, and it's not just cost efficient; it's also energy efficient as well, and it doesn't take up a lot of space. Again, sometimes you have more space to add things on a factory floor, sometimes you don't. When you talk about energy efficiency, let's take oil and gas or telco, for example, and you're deploying in a remote location where maybe you only have a generator to power things, or photovoltaic, etc. That energy footprint really matters as well. And especially if you can be doing it right where that data is being generated, you can start looking at things like predictive maintenance, right? And you can do things in a more efficient way so that the inferencing runs there, but you don't have to send all that raw data to the data center. You don't have to send all that raw data to the cloud, which is costly. And in a lot of cases, you don't have the right bandwidth to do it in the first place, right? So you can start looking at better planning for maintenance and operations. But also, privacy and security are very different at the edge as well. You're looking at deploying hundreds, if not thousands, of heterogeneous devices, across different geographies, right? You can't put the cloud in your pocket. You can't, sneak out. You don't have a trench coat big enough to sneak out with a large server, right? But some of these edge devices are small. You look at industrial pies, right? You can easily put that in your pocket. So considerations for privacy and security are different at the edge. But also, if you start adopting the edge and doing inferencing there, then the customer gets to choose the data gravity. And you need something where you can establish patterns so that you create a foundation for growth, right? We've talked a bit about low latency. My god awful bandsaw example, but also, again, if you're doing inferencing where that data is being created, then you have faster decisions, right? It's not that you're not being reactive; you can be proactive, and that's critical in the resource-constrained environments that we're operating in, right? And so that's really the advantages of edge AI. Why do we need these advantages? Why do we need to adopt these things now, right? Industry is changing, right? Customer demands are changing. How quickly customers need product or need data, et cetera. Whatever it is that the enterprise is producing, how that customer is asking for it, how they need it, is changing. That velocity is changing. We have new regulatory environments, right? All the time, different requirements, right? Anywhere from the EPA to the SEC. We need to have a solid enterprise grade flexible foundation for a customer so that they can react accordingly, so that it's not a huge lift every time something new comes down the pipeline. They have that foundation in place so that they can react accordingly, right? You've got new sustainability requirements, right? Also we have to do more with what we already have. There's a major shift towards operational efficiencies and getting more out of the machinery, or also just making our assets, making our machinery last longer, right? And that's why it's critical to be able to do Edge AI for predictive maintenance, so that we can take all that sensor data and actually do something in it and make it actionable, right? And also, critical new safety requirements, right? A lot of this machinery is fine and can run long, but sometimes you're talking about machinery that, if it breaks, it can be very dangerous, right? You don't think of a boiler as a dangerous machine, but a boiler can be dangerous. These are things that can explode, right? And it's not just about losing, months, if not, years with a factory being destroyed. You're talking about, people's safety, people's lives. And so it's critical to have a real-time viewpoint into how these things are operating, right? And you need intelligent solutions to drive the change, but you need intelligent solutions that can be layered on top. Getting back to that concept of, greenfield with brownfield roots, right? You're not doing a huge capex and redoing all the machinery. You've got machinery that works. Why throw the baby out with the bathwater when you can, with Edge AI, easily and cost effectively layer that in, right? And that's why you need these targeted models to be running at the device edge, right? Kind of pulling this all together, right? And making it so that you can add that intelligent layer, but add it the right way. And especially when you have different types of machinery, right? You're running, you're running your, anything from, Johnson Controls, Siemens, etc. Like you've got your Mettler Toledo, stuff, humming in there. You've got your CNC machines. How do you actually add that layer of intelligence without adding more costly machinery that, quite frankly, you know, machinery defined systems to affect modernization, they become outdated too quickly. You become locked into a solution, right? And that's where software defined solutions give you that flexibility, right? They clear bottlenecks and then they give you that foundation for growth, right? So they're flexible, they're scalable, right? And especially when you combine it with a good enterprise grade management layer. We're going to talk about our edge ops platform in a minute. It answers those security questions in the right way so that you're protecting data at rest as well as data in transit. And then you can also right size solutions. A lot of times when you're talking about something new, and especially when you're talking about AI in industrial settings, it's not an easy sell right now. People are starting to think about it, but it's not an easy sell. So you need to talk about right-sized solutions, and you need to talk about things where you can come in and you can start doing things, and then you can add on, and you can add on, and you can add on, you can change, and you could phase in, and you could phase out. But you need that flexibility. But that flexibility, especially for purposes of this call, comes with repeatability, with establishing patterns so that you can go in, so you can change, and you can scale, and you can really add that layer of intelligence on top of the existing equipment, as well as integrate with existing software systems that are already in place, and open it up for other ISVs, other software providers to start really leveraging this new infrastructure that you're creating on top of that machinery, so you can keep doing more and keep creating operational efficiencies and really enabling growth. I think a good example, is you look at a manufacturing company who, maybe we'll talk about food, right? Where they're doing processing right now, but they want to vertically integrate, they want to grow. Well, that's great if you want to start growing your own produce, but if the manufacturing plant is a bottleneck, then that's a problem. You can't properly vertically integrate. But if you can solve those bottlenecks and make it so the manufacturing plant is, a place of growth, then you're in a much better solution. Then it's not just about vertical integration, it's about vertical integration to growth, to market dominance as well. So again, we talked a little, we've talked about scaling, we've talked about the edge devices. Let's talk more, let's dig in more on the data itself, right? We need better data for better outcomes. We have to solve this garbage in, garbage out problem. Well, that edge data isn't new, but the ability to harness it is. That ability to create these targeted edge AI use cases, that run on these very small devices is new, right? And we really have to go after that, so that instead of the garbage in, garbage out, we're solving it right where that data is being created, right? And we have to do this in a way that enables us to take in all those diverse data sources, all the different sensors, all the different camera, all that telemetry needs to come in, right? From OPC-UA to Modbus, you have so many different protocols. Again, how do you make data science easier, right? And you do that again with a kind of proven, repeatable enterprise grade platform, right? Where you can bring in those diverse data sources and also enable pre-processing at the edge. If you're doing an edge motion, you don't want to be sending stuff to the cloud. It kills the efficiency of operating at the edge, right? You need to be able to better utilize that data that's being created, and you need to feed the models good data, right? Which is, why you need to enable, in certain, not in every instance, but in certain instances, you need to enable that pre-processing at the edge, so you're feeding the proper data to those models that are running at the edge. And so, in partnership, with Red Hat, we've built, the Guise Edge Ops platform, so that we can create those gateways, so that we can take all that data that's coming in different ways, and we can feed the models properly, and we can do it in a simple, easy to use, point and click fashion, right? I mean, if you look at it, from that high level point of view, from a business outcome, just look at the cost analysis of a data scientist, right? If they have to build something, if they have to build those data pipelines from the ground up every single time, if they have to build that infrastructure, it's taking time away from actually doing data science, actually creating powerful analytics. And so that's why we've brought that all together, so that from creation and deployment, on one side, and moving these edge workloads to the devices so that they can harness that data, to on the other side, being able to actually capture that data from these myriad data sources and bring it in and feed those models, and do it in a similar fashion to what Red Hat has done, which is enterprise grade for enterprises, right? A simple SaaS solution is not going to work here. There are too many different things at play here, from data acquisition to security, to device management and deployment, and kind of looking at that fleet as a whole. Uh, And so this is kind of just a simple overhead model where, on the left-hand side, you're looking at all these different data sources. You're harnessing them. You're bringing it in. You can do that pre-processing, and then, depending on the, whatever the protocol is, you're bringing the right way because different machinery has different protocols. You're taking that all in, and then you're feeding these devices in the middle. And then on the right-hand side, you're taking that image registry, for these purposes, we use Quay. So whether you have kind of a hybrid, edge to cloud motion, or whether you have to do everything on-prem and you have a private Quay, you're taking that image registry and then you can actually, send it to the devices. And so you have a beautiful flow, from kind of centering in to the edge devices here. Again, solving that garbage in, garbage out problem, and really, I don't quite want to use the word standardizing, but making this repeatable and making it scalable so that it's useful in the right way to customers. Naga, I'm going to hand it over to you to really kind of dig in on edge ops and the criticality of those patterns.
Yeah, thanks, Cindy. So, hi guys, nice to meet you all. So, we have taken the patterns that are needed to drive the day-to data science. Building a model is one aspect, but how do you inference the model at the edge is a different aspect altogether. So the models tend to degrade over a period of time for various reasons. How do you maintain the health of those models is where the edge ops platform can help the customers. We have built a no-code, low-code edge platform where serving the needs of the customers who do not have the expertise of Ansible or RHEL. So where we have all the models or the machine learning use cases sitting on image registry like say Quay, and we bring that to the edge server. And there are certain set of patterns that we have used, driving those models that are pulled in from Quay to orchestrate at these edge devices. With the click of a button, you can kind of orchestrate to an n number of devices. So, and at the same time, there are certain aspects that we got to cover when we do the inferencing. As Lindy was mentioning, security is one of the aspects. How do you make sure data at rest is intact? Because security of cloud is a different aspect when compared to edge. You have all these devices which are heterogeneous in nature, distributed across, and having, I mean, if you're able to access one of the devices, you're done. Like you are prone to all these malicious attacks. Like, how do you make sure that your devices are secured, both at rest and as well as in transit? And that's where we rely on Lux encryption and bringing the network-bound disk encryption with Tang and Clevis, to keep the data at rest, and as well as the TLS, where to keep the data in transit secured, and as well as the payload encryption, all towards the security aspect of the data at the edge. And at the same time, when we do this inferencing at the edge, we got to model these models. As I was mentioning, the models tend to degrade over a period of time, be it data drift or data distribution or things like those. A model that might be working in a particular geography may not be working in another geography, or it could be working well in a daytime, or it could not be working during night. How do you understand these patterns? And these patterns are all observed at the edge, where we have model monitoring sitting at the edge, but we need to collect the data so that we could provide those metrics, so that you could retrain the models to keep the models health intact, for the day to data science. So there are certain scenarios or patterns that we have followed, and some of them are highlighted here in terms of orchestration and as well as data collection and all those. Yeah, then we can. Yeah, John.
Yeah, I was gonna also say, for the folks that are familiar with the validated patterns that are already out there on our Red Hat validated pattern site, this is really kind of the next level detail for how the industrial edge pattern is set up. The pattern's a little long in the tooth these days, and so this gets into not just deploying that like edge inferencing use case, but then looking at how do we, just like we talk about day two with OpenShift, how we keep those models healthy and we save time from having to go out to the site, or how we can patch and model, update those models based upon data drift and model drift, like Doug is saying, and to be able to um, update the workloads for, like, I want to add new use cases because I've got new telemetry, or like Naga saying, how to keep the models healthy is based upon, particularly with computer vision stuff, like, seasons change, and the model that was trained was in a different season with different backgrounds, for example, or you're in a camera with a new location, and so that computer vision model is no longer giving you a good score. So those are just some simple examples of how you need this thing to be a living, breathing asset. Because once you build something, you put it out there to replace a human or another process. If it starts degrading in capability, management will definitely back up its strategy here. So, and this is the same thing for predictive maintenance models, in addition to computer vision, acoustics, all these things that we're trying to capture as business events in a space. We need to be able to ensure the best quality, and be able to make it have a way to operate it at scale. So these different patterns here about the whole life cycle of this stuff really augments that place of where you would run this in like a critical infrastructure, or for like a smart building facility where security is at stake, or the immutability of what we can do with Red Hat to create more of like an appliance can be augmented with these capabilities that Guise AI brings.
Lindy, can you go to the next one? Yeah, this is the high level architecture of what we do. So, we have all the use cases sitting on the quay. This could fit into any topology, be it on-prem or be it cloud. And the use cases could be from Guise AI. We have our own proprietary models serving some of the computer vision use cases, and as well as the predictive maintenance or the anomaly detections, in terms of the boiler, compressors, or the use cases needed for the industrial scenarios. So, and as we have these models available in QA, so the user gets the user can pick and choose what models they want to kind of orchestrate at the edge to do the inferencing. So, and as you could see here, all the edge devices that are connected to the edge server are all communicated with the help of Ansible to push the workloads with a click of a button. And at the same time, we have the gateway to read or collect the data from all the sensors, OPC-UA or Modbus or MQTT, and it expands as we go on. So, and also the security aspect in terms of covering both the data at rest and transit. And this is where the Lux and other things that we were mentioning is kind of coming in place. So as the data gets collected at the unified data store, it's nothing but an edge collector, edge data collector, where we bring all the inference data, drift data to a centralized or local storage, where the data collected, depending upon the requirement, if you want to use that, rich inference data to build a data lake, you could do that, or you could use that drift metrics in terms of data distribution and all, to push it to OpenShift cluster. And this is where, we have operators from Minayo and as well as the Label Studio, installed on, running on OpenShift, where, where the user has got the opportunity to label in case if they're following the supervised approach, and then feed that data to OpenShift AI, where the kubeflow pipelines are running, which are triggered from the jobs platform. So so that you can, so that the end user can pick and choose if the model has been trained enough by following or by observing the pre or post train metrics to make sure that the model is good enough to push it back to the quay, so that it could be reorchestrated back to the edge with the updated weights kind of thing. This is the overall architecture of what Guise AI does at the edge, to do inferencing. Yeah.
All right, so now we're actually going to show a demo. I think when you're building models, it depends. You can either enable, data science and data scientists and engineers, within an enterprise to build their own models. We're working closely with OpenShift AI, and really trying to put the power in the hands, of those, data scientists, in situ, in an enterprise, right? But in order to do that, it's not just about model creation, as we've shown here. It's about that ability to not just properly deploy, manage, and monitor those models, but also, create those data pipelines and bring in good data, into the models, running on those devices at the edge. And so, especially when we started picking up the conversation, with Anthony and with Martin, we were looking for, a use case that was a relatively universal problem. And one of those things, actually, again, getting into that idea of not having a huge CapEx spend and not, replacing everything, there are, millions, if not more, analog gauges that are operating in a field, and they're fine. But I was at a conference this spring, for energy, and had a guy, a field engineer come up to me and say, "Hey, we've got a problem that, we have these gauges in, for our generators to make sure that, there's enough fuel and there's enough propane to run the generators, but they're in very remote locations. We can't put wheels in motion and send people out there all the time just to check, you know, how full the tanks are. Does this actually work?" And we were like, "Yes, this actually works. You can simply point, a camera at the gauge, and then, running this model on a device close by. You can actually digitize this analog gauge, and either you can be sending, the data back, but if depending on the bandwidth, if you're out in a remote location and, LoRaWAN 5G aren't working, and, God forbid, you're using satellite communication, which is expensive, you just want to send that inference data. You want to send the JSON, right? To say it's gone, below a threshold. Now you need to put wheels in motion to either fill or replace that tank. I'm going to stop sharing this for one moment. I'm actually going to show a live demo of this.
Yeah, there's also a business case here where people are being offered to, upgrade to these smart valves, which are very expensive, and so, not just getting the readings off of these things, but also doing remote control. So you could actually fire the actuator through Modbus or OPC protocols. But yeah, the customer that Lindy was talking about had a whole group of propane tanks, and they go out, in order to improve their supply chain and all that kind of things, computer vision at the site would save them truck rolls, which, definitely is, in some cases, remote locations and places where it'd be very expensive to get there and show up and then have to turn around because you didn't have, propane on hand or whatever.
Exactly. It's that's spot on. And I think, as, we look to, establish patterns, it's not these one-off use cases per se. I think the use cases, like this are universal. It's how does it fit to that unique customer situation, and that's why it's critical that we kick off discussions like this. John or Naga, anything else on the demo before I switch back?
Yeah, the idea of we're capturing these business events to then create more intelligence for organization about how they're operating at scale have huge potentials for, oil and gas, paper and pulp. Any place there's a conveyor belt, right? Any place folks are having to go on site or go into hazardous areas. I've got a customer with a whole robot gym. So, we're doing fixed cameras right now, but putting cameras on moving robots for some of these use cases are creeping up in a lot of customers. So, where they have assets where it's expensive or dangerous to put someone in that location, they can replace that with a mobile drone or robot are scenarios where we can position this kind of edge management and keep the capabilities of that device always improving. So, but yeah, go ahead, Lindy.
I was just gonna just quickly summarize, all of this, in the criticality of doing inferencing at the edge, right? For the faster decision making, so that you can have real time insights. Again, moving, from being reactive to proactive it can't be understated how critical that is, especially in industrial environments, right? And that ability to really optimize production, again, in the way the customer needs, right? We talk about, we need to establish kind of these general patterns so that we can bring these solutions in, but the solutions themselves have to be flexible enough to fit the different environments. No two factories are exactly the same, and even if factories have the same layouts, you have different conditions, you have different temperatures, you have different times, for how long they run, different products, etc. And so you need the trust of an enterprise grade platform, and that's built with understanding those underlying patterns, right? But that enterprise grade platform has to enable growth. It has to be flexible. It's critical to avoid vendor lock-in, right? Because no one company is going to do everything for every customer. We have to enable new things to be created, new applications, new solutions, new AI, so that we can go after, new problems, new ways of doing things, enable, growth in a changing environment. And it's critical that we do it this way, and it's critical that it be easy to implement. It's scary how often we overestimate, you know, not necessarily the capabilities, but the capability in terms of what they can bring on for IT departments. There's so many times where where operations goes, this would be great, and IT just, they themselves don't have the bandwidth to do it. They can't learn new things, and so it's critical to do this, to make it easy to implement, these solutions, right? That it becomes, almost plug and play. To John's point, really creating these edge AI appliances that can be easily deployed in the field, that are cost effective, that are energy efficient. And again, having kind of that management layer that also does it in a secure manner, right? So that you can actually put that layer of intelligence over the existing equipment, so that it's not a multi-million, hundreds of millions of dollars CapEx to redo a factory. You can go in and start implementing this stuff day one easily and in the right way that enables that growth. So thank you all very much for your time today. Happy to open this up now to discussion.
Yeah, great. That was a great session. Thank you so much, Lindy. Yeah, I just kind of think about some of the other things I've seen over the years from Guise AI. And I remember the one demo that we had with, I think it was cans of bottles going across a conveyor belt and, checking for quality assurance and such.
Yep.
And yeah, it's definitely one of those things where we see this coming up over and over again. How do you go from the typical everyday industrial type of environment and bringing it into something where we can make use of the technology that we're running here at Red Hat and then beyond, right? So really appreciate the demo and the time that you took on this. Does anybody want to talk a little bit about how this is going to affect validated patterns? I see Martin Jackson's on the call, and Anthony. any thoughts on how we could use this in a pattern type deployment? I know we have things like industrial edge out there, and medical diagnosis comes to mind, although that's more of dropping images into a bucket. How do you think that some of the things that we saw in the demo here might affect some of the patterns that we currently have out there, or things that we could build upon?
Yeah, I think this is really interesting architecturally because it's a very different kind of use case for image recognition and vision types of AI algorithms than what validated patterns has highlighted in the past. So in the industrial edge pattern, we have data points that come from industrial gear, pressure readings, temperature readings that are intended to be acted upon locally. But the other, kind of models that we've had, visual AI sorts of techniques that we've applied to, have not been time sensitive in the way that gauge readings are likely to be time sensitive. Historically, the medical diagnosis pattern, for example, uses computer vision, but those computer vision assessments are for diagnosis purposes. And so by definition, they're not, seconds or minutes critical. They may be, hours or days critical, but they're not real time, necessary inferences to be made. So I think this is very interesting from that standpoint, because as Lindy pointed out with the bandsaw example very early in the presentation, there are an awful lot of mechanical decisions that are made that need to have millisecond precision, and there's real risk and real danger if those decisions can't be made.
Yeah, there's some organizations take this type of stuff as not necessarily the like their Emerson Rosemount readings is the truth, right? But there's a lot of use cases where computer vision is like they'll either call it IoT data or they'll call it just basic telemetry that may or not go into a time series database, for example. But from a pattern standpoint, to go to your question, part of this is using what is the Ansible GitOps pattern that you've worked on, Marty, that we've used with another oil and gas customer. And it's really just trying to build a model for deploying any workload at the edge in a secure fashion, is what this equates to with their EdgeOps platform, with just computer vision being highlighted as an example workload. And so how to build an edge infrastructure that's built, and we haven't really talked about boot C here yet, but in the future boot C based deployment with the capability to push or pull net new content, and then in the case of computer vision or just AI inferencing at the edge, the intelligence to be able to choose how you want those things updated and what data gravity the application's generating, to potentially, a lot of these architectures are now edge to cloud where they train the model in the cloud. And I think where Red Hat has an advantage is giving the customer choice, right, with the whole hybrid story, or sovereign data science, if you want to call it that, where they can build a model where it makes sense for their organization or their business model. And we've seen some things coming out of Red Hat research where by leveraging AI data science where you need to, there's advantages to be had. So we can use this as a way to deploy those. How do you there's a lot of cases where I've seen customers there's some guy who's done some great data science business model that only runs on his desktop, right? And so it's not impacting the business because they can't take the model and then deploy it where it needs to run. And with all the check marks that an enterprise requires.
Yeah, I think that's a great point. Taking it to the enterprise. How do you make this repeatable, extensible? These are all the things that we tend to address in the validated pattern SIG, you know, on a daily basis anyway, right? So it's yeah, it's one of those things, like, you can have some great minds to go out and create something that works, but is it supportable? Is it something that you can then extend out to other devices and such? So yeah, great points all.
Michael, I also appreciate from a partner perspective that we're working together on this. And this is a really cool use case, solving a business problem. It's not a made up problem. This is something that we see all the time from our, especially industrial customers, where you have hundreds of thousands of these individual dials out there that you can't do anything with to get the data out. I mean, they're just sitting there helping, doing their job, but this use case highlights a very innovative problem, or an innovative solution for that common problem that we're going to see more and more of over time.
Yeah,
I'm also interested in people's, I mean, because there's lots of people on this call. If there are additional questions, we didn't really open it up for very long for the use case or for working with guys directly.
I really enjoyed the presentation. On the I think you had a line that was pointing to the sensors and in your diagram, and in the diagram I was wondering, was that line Kafka or a WISM or WebAssembly, and or can you do this without those?
Yeah, we are doing without those. We have the clients built for several protocols, and as well as integration with several other partners like the Matricon or Ignition Edge, where they have a lot of sensors, that are talking to their OPC UA servers. For instance, Matricon Data Broker, they have this data broker where they talk to sensors which are communicating via their own legacy systems, and we rely on the clients of various protocols to talk to them and start collecting the data. Once the data is collected, that's where the MQTT Spark Plug B comes in to move the data from these gateways to the edge devices, and also from the edge devices to the unified data store to the OpenShift AI.
Awesome. No, that's awesome.
Any other thoughts, comments?
Yeah, I'll just say this is another demo continuing our building of a whole brewery. So that image was taken of my brew pod. So we've got the labeling done. We've got some of the operational concerns of the brewery built. We just need to work a little bit on the chemical testing automations.
Hey, those concerns are real safety concerns. When I was in college, there was a fairly major incident when someone got one of those big glass jugs of apple cider and didn't cap it properly and inadvertently brewed, some apple cider vinegar slash, alcoholic apple cider. It exploded in the dorm room and caused quite a mess.
Yeah, I've seen that happen with kombucha.
It's gonna make a kombucha joke.
Yeah,
You're
you
making
need really
apple.
thick glass.
Is there such thing as an apple tapachi? So,
Yeah, there is actually, I think.
yeah.
Oh goodness.
It sounds like they should have figured out how to charge for that a little more.
Minus the glass shards, but yeah.
Yeah.
Well, yeah. Details.
Cool. Well, if there are no other comments, I did want to just put a few links into the chat here, and maybe I'll share my screen real quick too. Really appreciate you coming in and doing this presentation for us today. If folks that are online or watching the replay would like to see more about upcoming sessions, you can go to red.ht/commons-vpsig-agenda. We have the agenda, and any notes and links will be available there. Or please go ahead and submit a future session if you're interested in talking. And Also, I just wanted to take a quick second here to introduce a new data special interest group that I'll be leading starting this month. So if you're interested in data of any sort, please come and join us, and you can take a look at the agenda there.
Outstanding. Michael, Anthony, Danielle, John, just wanted to thank all of you again for having us on today. It makes it a joy doing what we do, having partners like you guys that we can keep pushing on behalf of our customers to get better solutions out there. So thanks, guys.